This lecture is about web search. In this lecture, we're going to talk about one of the most important applications of text retrieval, web search engines. So let's first look at some general challenges and opportunities in web search. Now, many information retrieval algorithms had been developed before the web was born. So when the web was born, it created the best opportunity to apply those algorithms to major application problem that everyone would care about. So naturally, there had to be some further extensions of the classical search algorithms to address some new challenges encountered in web search. So here are some general challenges. First, this is a scalability challenge. How to handle the size of the web and ensure completeness of coverage of all the information. How to serve many users quickly and by answering all their queries. Right? So that's one major challenge. And before the web was born, the scale of search was relatively small. The second problem is that there's low quality information, and there are often spams. The third challenge is dynamics of the web. The new pages are constantly created, and some pages may be updated very quickly. So it makes it harder to keep the index fresh. So these are some of the challenges that we have to solve in order to build a high-quality web search engine. On the other hand, there are also some interesting opportunities that we can leverage to improve the search results. There are many additional heuristics. For example, using links that we can leverage to improve scoring. Now, the algorithms that we talked about, such as the vector space model, are general algorithms. They can be applied to any search applications, so that's the advantage. On the other hand, they also don't take advantage of special characteristics of pages or documents in a specific application, such as web search. Web pages are linked with each other, so obviously the link information is something that we can also leverage. So because of these challenges and opportunities, there are new techniques that have been developed for web search, or due to the need for web search. One is parallel indexing and searching, and this is to address the issue of scalability. In particular, Google's invention of MapReduce is very influential and has been very helpful in that aspect. Second, there are techniques that are developed for addressing the problem of spams, so spam detection. We have to prevent those spam pages from being ranked high. And there are also techniques to achieve robust ranking. And we're going to use a lot of signals to rank pages so that it's not easy to spam the search engine with a particular trick. And the third line of techniques is link analysis. And these are techniques that can allow us to improve search results by leveraging extra information. And in general, in web search, we're going to use multiple features for ranking, not just link analysis, but also exploiting all kinds of clues like the layout of web pages or anchor text that describes a link to another page. So here's a picture showing the basic search engine technologies. Basically, this is the web on the left and then user on the right side, and we're going to help this user to get access to the web information. And the first component is a crawler that would crawl pages. And then the second component is an indexer that would take these pages to create an inverted index. The third component is a retriever that would use the inverted index to answer a user's query by talking to the user's browser. And then the search results will be given to the user, and then the browser will show those results and to allow the user to interact with the web. So we're going to talk about each of these components. First, we're going to talk about the crawler, also called a spider, or a software robot that would do something like crawling pages on the web. To build a toy crawler is relatively easy because you just need to start with a set of seed pages and then fetch pages from the web and parse these pages to figure out the new links and then add them to the priority queue and then just explore those additional links, right? But to build a real crawler actually is tricky, and there are some complicated issues that you have to deal with. So for example, robustness. What if the server doesn't respond? What if there's a trap that dynamically generated web pages that might attract your crawler to keep crawling the same site and to fetch dynamically generated pages? There is also this issue of crawling courtesy, and you don't want to overload one particular server with many crawling requests, right? And you have to respect the robot exclusion protocol. You also need to handle different types of files. There are images, PDF files, all kinds of formats on the web. And you have to also consider URL extension. So sometimes those are CGI scripts, and there are internal references, etc. And sometimes you have JavaScripts on the page that they also create challenges. And you ideally should also recognize redundant pages because you don't have to duplicate those pages. And finally, you may be interested to discover hidden URLs. Those are URLs that may not be linked to any page, but if you truncate the URL to a shorter path, you might be able to get some additional pages. So what are the major crawling strategies? In general, breadth first is most common because it naturally balances the server load. You would not keep probing a particular server with many requests. Also, parallel crawling is very natural because this task is very easy to parallelize. And there are some variations of the crawling task. And one interesting variation is called focused crawling. In this case, we're going to crawl just some pages about a particular topic. For example, all pages about automobiles. Right? And this is typically going to start with a query, and then you can use the query to get some results from a major search engine, and then you can start with those results and then gradually crawl more. So one challenge in crawling is to find the new pages that people have created, and people probably are creating new pages all the time. And this is very challenging if the new pages have not been actually linked to any old page. If they are, then you can probably find them by recrawling the old page. So these are also some interesting challenges that have to be solved. And finally, we might face the scenario of incremental crawling or repeated crawling, right? So let's say if you want to build a web search engine, and you would first crawl a lot of data from the web. But then once you have collected all the data, then in the future, you just need to crawl the updated pages. In general, you don't have to recrawl everything, right? Or it's not necessary. So in this case, your goal is to minimize the resource overhead by using minimum resource to just still crawl the updated pages. So this is actually a very interesting research question here, and it's still an open research question in that there aren't many standard algorithms established yet for doing this task. Right? But in general, you can imagine, you can learn from the past experience. Right? So the two major factors that you have to consider are, first, will this page be updated frequently? And do I have to crawl this page again? If the page is a static page that hasn't been changed for months, you probably don't have to recrawl it every day, right? Because it's unlikely that it will be changed frequently. On the other hand, if it's a sports score page that gets updated very frequently, and you may need to recrawl it maybe even multiple times on the same day. And the other factor to consider is this page frequently accessed by users? If it is, then it means it's a high utility page. And then it's more important to ensure such a page to be fresh, compared with another page that has never been fetched by any users for a year. Then even though that page has been changed a lot, then it's probably not necessary to crawl that page, or at least it's not as urgent as to maintain the freshness of a frequently accessed page by users. So to summarize, web search is one of the most important applications of text retrieval, and there are some new challenges, particularly scalability, efficiency, quality information. There are also new opportunities, particularly rich link information and layout, etc. Crawler is an essential component of web search applications. And in general, we can classify two scenarios. One is initial crawling, and here we want to have complete crawling of the web if you are doing a general search engine, or focused crawling if you want to just target at a certain type of pages. And then there is another scenario that's incremental updating of the crawl data, or incremental crawling. In this case, you need to optimize the resource. Try to use minimum resource to get the needed fresh information.